AB Calculus Notecard 64, Extensions of Fundamental Theorem of Calculus. This is the 64th video lesson in the series inspired by Stacy McMullen, formerly of Dowson Independent School District, who developed the Notecard system. This lesson builds upon Notecard lessons 62 and 63 using the Fundamental Theorem of Calculus. And for this, what we're going to do is look at some other applications. Sometimes you're going to see in area finding a constant k. We're going to see a problem like that when the area under the curve is known. And the next three situations here, 2, 3, and 4, have to do with real-world applications of calculus. So if you have a rate, the integral of a rate is going to use the fundamental theorem of calculus to find how much, in this case, the rate of water flowing, how much water came into the tank. So the integral of a rate is an amount. Displacement, the integral of a velocity, for instance, will be the net displacement or net distance over a given time. Terminal value, the integral of a rate is a value. So if we have remember we had this thing here. If we subtract f of a from both sides of this equation here, we have the integral from a to b of fx dx is f of b minus f of a. This right here is a hyphen, not a negative sign or a minus sign. And then f of a will be the initial value. So using the fundamental theorem of calculus. Okay, three problems here. The first one, if the integral from negative 2 to 2 of x to the 7th power plus k dx is 16, then k equals question mark. Now, if we understand what that function of y or fx equals x to the 7th power looks like, that's going to simplify this problem enormously, but we're going to just plead ignorance and split up these two terms as separate integrals. So that's going to be equal to the integral from negative 2 to 2 of x to the 7th power dx plus the integral from negative 2 to 2 of k dx. And we know that these two now separate integrals together are going to be equal to 16. So if we can find what this value is here, the integral from negative 2 to 2 of x to the 7th power dx, that's going to make us able to solve for k. So I'm going to take this first integral on the left and kind of work it up here. So we have the integral from negative 2 to 2 of x to the 7th power dx. I already know what this is, so I'm pleading ignorance at this point. What we're going to have is x to the 8th power divided by 8, and we're going to evaluate that from negative 2 to 2. So what we have is f of b, so we have 2 to the 8th power over 8 minus negative 2 to the 8th power over 8. Now when you simplify this 2 to the 8th power is, I don't know what it is, but you're going to get the same thing in each instance. So you're going to have one quantity minus that same quantity, or 0. So now we know that this value here is 0. So now we have 0 plus the integral from -2 to 2 of k dx is equal to 16. And the reason that I knew what this was going to lead to in the first place is the understanding of what x to the 7th power looks like of the function. It's going to look like this. So you're going to have a symmetry here. So between -2 and 2, you're going to have these two areas that cancel each other out and net is 0. Okay, working to the right, we're going to have the integral of k dx is going to be k, and we're going to evaluate that from -2 to 2, and I'm just going to set the equation is equal to 16. And so working below, we have k is 2, it's going to be kx. Okay, so we're going to have 2k that's going to be our f of b, and minus f of a is going to be minus -2k, because we had kx, right? And that's going to be equal to 16. So what we have here is 2k minus -2k, we have 4k is equal to 16. And working to the right, finally, we have k is equal to 4. And then to test, we could go back if we had to substitute in and see that's the case, but this will be our answer to problem number 1. Next, free response problem. A metal wire of length 8 centimeters is heated at one end. The table gives selected values of temperature T of x in degrees Celsius of the wire x centimeters from the heated end. Find the integral from 0 to 8 of t prime of x dx and indicate units of measure. Explain the meaning in terms of the temperature of the wire. Well, you have this table is the integral, and so we're going to just look at this data. And here we have at 0 centimeters from the end, we are heated to 100 degrees Celsius. Boiling point of water, by the way. And then, as we proceed farther along the wire, we can read a cooler temperature, or sense of cooler temperature. So what does this mean? Well, the integral of the rate is the amount. So this is the amount we're looking at. So we will say integral from 0 to 8 of t prime of x dx is equal to this value right here, okay? 55 degrees Celsius. Explain the meaning. in terms of the temperature of the wire. Okay, and 8 centimeters from the heated end of the wire the temperature, I'll just abbreviate temperature, is equal to 55 degrees Celsius. That's it. So in explaining, we're looking for just an explanation in common language in English in this case. Okay? So really, a lot simpler than it looks. We just have to be able to interpret what the prime is to get to the, not prime, get from the rate to the amount. Okay, last one, a calculator problem. A particle moves along a straight line for t is greater than or equal to 0 and less than or equal to 5. So the velocity is v of t equals -2 plus quantity t squared plus 3t to the power of 6/5 minus t cubed, and the position of particles given by s of t. So s of t, we have to understand that is going to be the integral of v of t dt. Okay? And let's go ahead and look at what that is. It is also known that s of 0 equals 10. We want to find at time t. So we are looking for s of t when t equals 5, so s of 5. So if we take the integral of this, we will get our integral function. So s of 10, no, s of 5 is what we're looking for. It's going to be equal to our starting amount. And looking back here, displacement, where does it say starting amount? It doesn't say that, but here in 2 accumulation, we have to consider a starting amount to and then the displacement and so forth. Let's go on here. So s of 5 is going to be equal to s of 0 plus all this from 0 to 5 v of t dt. So that's going to be equal to s of 0 is 10. Yeah, 10 is going to go replace that s of 0. So you have 10 plus the integral from 0 to 5. And then we have this whole function right here is going to replace, is going to be v of t dt. And I'm not going to rewrite this. I'm just going to go to the calculator. So now going to our T-Inspire CX calculator. We're going to take the integral, but first we're going to add that 10. Remember we had that s of 0 equals 10, so we have 10 plus. Now I'm going to show you an integral hotkey. If you press shift and the minus sign, well, I got the wrong one there. That's the differential. Let's do that again. Shift and the plus sign. There we go. So we're going to go from 0 to 5. And we're going to put v of t here. Well, v of t is going to be -2 plus, and we're just writing it in as is. One thing we look for is we don't have a trigonometric ratio, but if we did, we would make sure we were in radians. That's one thing to look out for. So we have 3t to the power of 6/5. And over here, we have minus t cubed and we have dx finally. And we enter, no variable is not defined, okay. Let me try that again. N plus the integral 0 to 5. I don't know what they didn't like here. We're going to have -2 plus x cubed, x squared plus 3x to the power of 6/5. And what I want to do is try to use a different variable here. I'm going to just use t. See if this helps us out. Oops. 3t. We come here, and we're going to have minus t cubed and dt. I hope this works better. Yeah, it does work better. So that's what it is. -9.207. And in AP standards, we want to go to 3 decimal places. So -9.207. Okay. Along the straight line. So we'll just say S of 5 equals -9.207. I would look for units if I could. Does it say anything about inches, centimeters, meters, kilometers, or anything? No, that's going to be it. So that is our answer. I hope this has been helpful to you. Good luck, and thanks for viewing.